So welcome everyone to chapter 2 of the image processing module. So in this chapter we're going to look at binary images. So a binary image in its classical definition is an image where each pixel can take only one of two possible values. Typically these are represented as 0 or 1, but in some cases you may find binary images represented by the values 0 and 255. So a binary image, if we were to take the former of those two definitions, is really a mapping from the discrete plane, so a grid on a plane, which is given by z squared. So you've got integer coordinates for the row values and integer coordinates for the column values. And the image is a mapping from that spatial spatial grid onto values of 0 or 1. So note that this is a set rather than a continuous domain. So binary images are often produced as the result of some kind of decision process that's applied to the pixels of an input image. Pixels in the output image are usually set to 1 if the current image or the corresponding input image pixel satisfies some criterion or criteria, and set to 0 otherwise. Binary images can also be referred to as logical or Boolean images. They're very widely used in image processing and computer vision, and by creating a binary image we're usually creating something that can also serve as a mask that specifies regions in the image where some property or condition is true for all the pixels in that region. For example, if one were to write an algorithm to count the number of biological cells in a culture dish or in a histology image, then at some stage in the algorithm it's sensible to produce an intermediate image whose pixel values contain 1s where there is a cell present and 0s in those locations where there is no cell present. So this is sometimes also referred to as a masking image in some packages, or let's say in some processes or descriptions of the process of creating a binary image or using a binary image. Thresholding is one of the techniques that is most commonly used to turn a grayscale or a color image into a binary image. For grayscale images, thresholding is usually, I should say often, a means of distinguishing pixels that have a higher intensity from those of lower intensity. So if we have an input image which is given by f, or denoted f as a function of m and n, then you can create the binary image g as a function of m and n by this. So this means that for every m and n, or for each m and n, if the intensity at location mn is greater than or equal to a threshold, then you set the corresponding pixel at in the output image to be equal to 1, else you set the pixel value to be equal to 0. So that's very simple, very straightforward. You can also look at applying this thresholding in such a way that the values gmn take a value of 1 if the intensities are less than a threshold, or less than or equal to a threshold. But conventionally, I think greater than or equal to is usually the way people think. But in one of your practicals, you're actually going to see a case in which you want to apply a threshold and take pixels that fall below that threshold and identify those as, or label those as being 1 or 0. Oh, sorry, label those as being 1s. Okay, so let's take a typical application of a thresholding operation. So we're going to start off with a very simple image where it's a grayscale image containing values in the range 0 to 255. And what we're going to do is to perform this thresholding operation in a simple way so that we intuitively label pixels that are brighter or that correspond to one type of object in the image with ones and other pixels with a zero. So we're going to refer to the pixels that have a 1 as belonging to an object of interest, and the pixels that are labeled 0 will correspond to the background, which is the definition that we've used for this particular demonstration. So the example image is shown here. Here is it's a leaf on grass image. This was actually taken in Kensington Gardens, you'll be happy to know, and it's done one autumn. So there was a leaf lying on the ground. It was one of the first leaves to have fallen that autumn, and I decided to take a snapshot of it. And so this is the result of the thresholding process. So I've used a threshold in this case of 140, and that was set kind of arbitrarily. I'll show you how you would go about setting a threshold more precisely. But the net effect of this is that because the pixels belonging to the leaf are on average brighter in intensity than pixels belonging to the grass, then by setting a threshold you get predominantly this large group of pixels labeled as object in image 1B, and to a large extent the pixels belonging to grass are labeled with zeros. Now, this is not a perfect process, and I've left this image in because almost no thresholding process based on a single intensity level is going to be perfect. But this is not a bad start, because you can see that you've got quite a nice big clump of pixels belonging to the leaf within this image. Now, the obvious question that springs to mind is how do you set a threshold for something like the leaf on grass image? And in particular, what should the value of t be so that we get the best labeling in some sense? So the way to answer this question is actually by looking at a histogram of the grayscales present in the image.